topic for today will be multiplication of vectors. So there are two kinds of products, or there are two ways in which we can multiply vectors. One is which is known as the scalar product, and the second one which we call it as the vector product of two vectors. So we'll discuss both of these one by one. Might be most of you know about this from before, but today we'll just revise what this scalar product is and what this vector product is. So let us say we have two vectors A and B. So these two vectors, first we'll write them in their component form. We talked about writing vectors in the component form. So let's say A is equal to I, which is the unit vector, AX plus J AY plus of K AZ. So AX is the component of the vector A along the x-axis, AY is the component of the vector A along the y-axis, and AZ is the component of the vector along the z-axis. Similarly, B, we can write it as IBX plus JBY plus KBZ. So these two vectors, we can find out the scalar product and also the vector product. How they are defined? The scalar product is defined as A dot of B. We call it the scalar product, and the vector product of these two vectors, we call it as, define it as A cross of B. So what are these? These are two kinds of operations that we can do with the two vectors. This is known as the scalar product and this is known as the vector product. Now let us see what this operation means. Okay, so we have the two vectors A and B. So the dot product, the scalar product is also known as the dot product. The scalar product or the dot product A dot of B is defined as the magnitude of the vector A. We are talking about a vector, so it will have its magnitude and direction. So magnitude of the vector A multiplied by the magnitude of the vector B into the cosine of the angle between the vector A and B. Let us say this is vector A, this is vector B. The direction of the two vectors, it makes an angle theta. So the dot product or the scalar product of the two vectors is defined as the magnitude of the vector A into the magnitude of the vector B into cos of the angle theta, which is the angle between the vector A and the vector B. So what does this mean? So simply this dot product or the scalar product, the result of this product result is a scalar. This we need to understand. The result of the dot product of two vectors or the scalar product of two vectors is a scalar, hence the name the scalar product. And similarly, the cross product or the vector product of the two vectors is defined as the magnitude of the vector A multiplied by the magnitude of the vector B into sine of the angle theta between the two vectors and this vector product happens to be a vector with a unit vector n, which denotes the direction of this cross product. So the result of the vector product is a vector, means it has a direction. So what is the physical significance of this scalar product and vector product? This is important. The physical significance of the scalar product, it simply means the magnitude of the vector A and the projection of the vector B along the direction of A. So if I draw it a bit bigger, it's something like this. So this is vector A, this is theta, and this is B. So B cos of theta is nothing but, so if I say this is the magnitude, this length of this, let's call it OB and let's call it OA. So what it simply means is OB is equal to the vector B, OA is equal to the vector A. So A into B cos of theta. So B cos of theta term, it's nothing but the magnitude of the vector A into the projection of, we call it a projection of B along A. So this is the physical significance. So imagine the best example of projection is a shadow. You can imagine, let me say I'm keeping the pen here, something like this, along the vector B. If a light is made incident from this direction, what will be the shadow of this vector along the direction of A? So this will be the length of the shadow. So that is the projection of B along A. Right. So this is the physical significance of the scalar product. Is simply the product of one vector multiplied by the projection of the second vector along the first vector. The scalar product of two vectors, it depends on the angle between the two vectors. So this is an important point. The scalar product of two vectors is dependent on the angle between the two vectors. So A dot B, as we wrote down, A dot B is equal to magnitude of A and the product of the magnitude of B along the direct projection of B along the direction of A. So it depends upon the angle theta between the two vectors. This is the angle theta between the two vectors. This is A, this is B. So it depends on the angle theta between the two vectors. So if theta is 0, then cos of theta is equal to 1. If theta is 90 degree, then cos of theta is equal to 0. In case of the unit vectors in the coordinate system that we discussed about, this becomes important when we talk in terms of the components of a vector. We are talking about the unit vectors I, j and k. It represents x, y and z axis. For the unit vectors I dot of I, unit vectors means these have unit magnitude. So this is into I, magnitude of I into magnitude of I into cos of theta. So two vectors in the same direction, I dot I, so this is equal to 1 into cos of theta. Cos of 0 is 1, so that is 1. So I dot of I is equal to 1. Similarly, I dot of j is equal to magnitude of I into magnitude of j cos of theta. In this case, theta between I and j, this angle is equal to 90 degrees, so it becomes equal to cos of 90 degrees 0, so this becomes equal to 0. Similarly, j dot of k is equal to 0, I dot of k is equal to 0, and also j dot of j will be equal to 1, and k dot of k will be equal to 1. So these values become important when we talk in terms of the scalar product of two vectors in its component form. See what happens in component form. So A is equal to I ax plus j ay plus k az. B is equal to I bx plus j by plus k bz. Therefore, A dot of B will be equal to, we can write it as I in component form, I ax plus j by plus k bz dot of, sorry, this will be rather j ay class plus k az dot product with I bx plus j by plus k bz. So if we multiply this, so it will be the dot product of I dot of I dot of j, we have to multiply all the terms. So here you get I dot of I ax bx, this is the first term. Then I get a cross term, we call it a cross term, I dot of j ax by plus I dot of k ax bz plus with the second term j dot of I ay bx plus j dot of j ay by plus j dot of k ay bz. Then with the third term k dot of I az bx plus k dot of j az by plus k dot of k az bz. Right. So these products, the cross terms will all go to 0 because I dot of I is 1, I dot of j, this is equal to 0, I dot of k is equal to 0. Similarly, all these cross terms with the unit vectors, they will become 0, and I dot I, j dot j, this term is equal to 1, this is equal to 1, this is equal to 1. So only these three terms will remain. So this becomes ax bx plus ay by plus of az bz. The vector product or the cross product of two vectors A and B is defined as A cross of B is equal to magnitude of A into the magnitude of B into the sine of the angle between the two vectors, and the product is a vector. The cross product of two vectors is a vector, and this n is a unit vector, we call it a unit vector, which gives the direction of the cross product. right? It gives the direction of the cross product. So if I have two vectors, let me say A along this direction and B along this direction, this is the angle theta. So A cross of B, the product A cross of B, as we said, is a vector, and the direction of the vector is in a direction perpendicular to both A and B. It's in a direction which is perpendicular to both A and B. Means this is perpendicular to the plane containing the vectors A and B. So if we can imagine a plane like this, right? If you can imagine a plane like this, so this is a plane, let us say. So the product, cross product, the vector, which is a vector, will be in a direction perpendicular to both A and B. So this vector product also depends on the angle between the two vectors. It depends on the angle theta between the two vectors. So if theta minimum can be equal to 0, if theta is equal to 0, sine theta is equal to 0, so the cross product becomes equal to 0. So A cross of B in this case will be equal to 0. Other way around, if theta is equal to 90 degree, then sine theta is equal to 1. So A cross of B becomes equal to magnitude of A into the magnitude of B. It's a vector. Okay. So if we talk in terms of the unit vectors I, J and K, as we saw in the earlier case, the angle between I and J is equal to 90 degree, I and K is equal to 90 degree, J and K is equal to 90 degree. So I dot of I is equal to 0 because angle between them is 0, sine 0 is 0, so it becomes equal to 0. So J dot of J, cross rather, J cross of J is equal to 0 and K cross of K is equal to 0. And the other way around, the cross products, I cross of I cross of J is equal to 1, J cross of K is equal to 1, K cross of I is equal to 1. Okay, what is the physical significance of this cross product? Let me say this is a vector A and I have a vector B along this direction. So this is the angle theta. So if I consider the magnitude of B, the magnitude of A, B, so A cross of B, as we wrote down, is equal to A magnitude of B sine of theta into the unit vector n. So B sine of theta is equal to this much. This is the magnitude of B sine of theta. So if we form a parallelogram, say we form a parallelogram with two vectors as the sides of the parallelogram, what this product gives me, total product gives me, it gives me the area of the parallelogram. This is the physical significance of parallelogram. The cross product of two vectors, it gives us the area of the parallelogram of which the two vectors A and B are the sides. This is the physical significance of the cross product of two vectors. So if you see this cross product in component form, then you can write it as A is equal to IAX plus JAY plus KAZ. B is equal to IBX plus JBY plus KBZ. Then the cross product A cross of B is equal to IAX plus JBY plus KBZ cross of IAX plus JAY plus of KAZ cross of IBX plus JBY plus of KBZ. So we have to take the cross product. So this is I cross of I AX BX, I cross of J AY BY, I cross of K AX BZ. So the cross terms will remain. I cross of I gives me 0, J cross of J gives me 0, K cross of K gives me 0. So we have the terms, I cross of J AX BY plus I cross of K AX BZ plus J cross of I AY BX plus J cross of K AY BZ plus K cross of I AZ BX plus K cross of J AZ BY. Only the cross terms remain. So I cross of J is equal to K, so we have K AX BY plus I cross of K is equal to minus of J AX BZ plus J cross of I is equal to minus of K AY BX plus J cross of K is equal to I AY BZ plus K cross of I is equal to J AZ BX plus K cross of J is equal to I AZ BY. If we bring together all the terms, we can write it as I, J and K, AX, AY, AZ, BX, BY, BZ. So this is important. The cross product of the two vectors in component form can be written out as the determinant. So that is all for today. Next class we'll talk about a bit more about scalar product and vector products.